my name is Henry from Codeversity, and in today's video I'm gonna present to you this TypeScript crash course. In this course you're gonna probably learn the basics, fundamentals, advanced tricks, and much more. You're gonna be able to watch this entire video and later on get cracking on your own, build your own project, and try things out. So what we are waiting for? Let's just jump in the course and let me start presenting to you the magic of TypeScript. So the first things you guys gotta know in this course is that it's split in 11 sections. Throughout the course, the complexity is gonna grow, of course, but we are gonna begin very slowly from starting what you need to learn before this course and the best ways for you to catch everything very quickly. And later we're gonna cover setup, fundamentals, like how you declare basic types and you debug and you configure everything, until the advanced tricks, which is tumbles and a lot more in the course. And finally, we are gonna give a little hint into what is next for TypeScript and what is the latest news into 2023, so we can learn a little bit more of what is going on. So first of all, what do you need for this course? Obviously, you're gonna need to learn a little bit of programming before taking this course. And it's very important you learn the JavaScript fundamentals. You need to be very acquainted with variables, arrays, objects, functions, arrow functions, the structuring, pretty much the basics of the language before you jump in on TypeScript, or you're gonna feel a little bit lost. I'm not gonna lie to you. So before and during the course of this course, it's really important that you have these steps and tips for you to learn way quicker. I'm gonna really summarize everything. I'm not gonna talk about anything that is not important in TypeScript, so I really recommend you to watch the entire video. And throughout this video, I highly recommend you take notes, especially for important questions that might pop up on an interview. It's really important. And after this course, I highly recommend you to practice. Maybe create a crude application or a small application on your own. It will be the best way to practice alone. Of course, you can follow this course, you can code with me, but I highly advise you take your own steps towards learning as well after this course. It's really important. I cannot express enough. As a self-taught developer, it's really important that you guys get the practice. The basic questions that come up when we're learning TypeScript. That is, what is TypeScript, why use it, and how is it different to JavaScript? So let's think about this. TypeScript seems to be like a brother to JavaScript. JavaScript is this really messy kid. It runs around in the parking doing a lot of tricks and jumps. It really knows how to get things done, to say, but it's very disorganized. And TypeScript, on the other hand, is that kid that is an angel. You know what's gonna do, you know how to predict this kid and how it plays in the playground. I really like to use this analogy, but in summary, TypeScript, technically, it's a language built on top of JavaScript. So everything that you build on JavaScript is gonna probably work with TypeScript. The only main differences is that it's more organized. So you gotta give it some directions. So one of the benefits of TypeScript, especially, is static typing, code completion, and refactoring. It's really important. It helps teams sync faster in a large application and medium-sized applications. And it gives some shorthand notations as well, which is pretty great. So if you're jumping in on a code that you don't know the code base, that is really complex, it's really easy for you to catch up and just understand what variable does what and how they work overall in the entire application. So what is static typing? Static typing, it's pretty common in C++, C#, or Java. In summary, it's pretty much if you go in Java, if you have done Java before, you have ways of declaring a variable, for instance, an int for a number, like we are seeing on the example, but it's not mutable. What I mean is you cannot change this type for another very different type. For instance, in the example, number turns a float from an int, it's not gonna work, or number is gonna turn a string or receive a string is not gonna work whatsoever, it's gonna throw an error. Now, in dynamically typed languages, for example, JavaScript, Python, Ruby, it really doesn't matter. You can add any value or even declare a variable that is a number and later on pass a string. That's not a problem whatsoever on these languages. There is good and bad in this scenario. The good is there is flexibility, but the bad is that the code base can turn to be a mess really quickly. So imagine you start a variable that is a number and then it ends up receiving, I don't know, an array of strings. It's really becoming very confusing, and if you are in a large application, these things cannot happen, or you're gonna waste a lot of time into debugging and creating new features. So that's why Typescript comes into place. It adds some really spicy things to JavaScript that we didn't have before, or that was really hard to do. Even though in JavaScript we have something called prop types, which is pretty similar to adding some types to variables and things, it's still very complex to do. It's not something that you would usually use in an application. Nowadays, TypeScript is becoming more popular because it makes it easier to declare the types. So new features, type checking, refactoring, code compilation, together they make a better development experience. Well, not everything is flowers. In the technology world, you have benefits and drawbacks. In drawbacks, we can see that since TypeScript is built on top of JavaScript, we have a compiler. That you put in JavaScript on one end and it does something and goes out on the other end JavaScript. It's pretty much a compiler. A compiler is just a way for it to interpret what we are putting in. So remember when I told you about prop types, it's pretty much you use in JavaScript, and TypeScript does something similar, but in the end, it's everything JavaScript. Of course, without going even deeper on the architecture, on the compilation, that is not really important to this course, you also start noticing that you need some discipline to code on TypeScript, because you always need to declare types, and you always need to be guiding the code itself with these type notations, and it requires a lot of discipline. That's why you really use mainly TypeScript in large and medium-sized projects, because if you build something like an MVP or a small project with TypeScript, it wouldn't make much sense, because it would add a layer of complexity to this application, and of course it could generate some issues when you want to build or release this application on production. It really adds this layer of complexity, and it really needs to be justifiable to use TypeScript. So it's like I say, you're not going to use a bazooka to kill a bug. You won't use like a huge machine to solve a very small problem. Normally TypeScript is recommended to use when you have large teams or a really high round of developers working on this project, and they need to get really acquainted with the code faster. So TypeScript comes to play. Into installing a TypeScript, you're gonna pretty much need Node. as a standard for you to be able to run TypeScript. If you do have already Node in your computer, it becomes easier. I'm pretty much following the principle that you already have JavaScript and Node. If you don't have, just go on the Node website and download the earliest version or the latest version. And well, it's pretty straightforward for you to install TypeScript. If you are in Mac, you do sudo npm install globally, let's down globally TypeScript. It's gonna ask for you to put your password, and then it installs the package, pretty much that. If you wanna check if it is installed correctly, you just do a quick tsc-v, and it's gonna pretty much throw you the version of TypeScript that you have at the moment. So the version that you're gonna be working in this course is, as you can see, 5.3.3. Well, this is pretty much standard for you to run TypeScript. So let's jump in right into the next topic, which is your first program and app with TypeScript. Really excited. Let's go there and get our hands dirty. First things first, create a folder and then you can open that on your VS Code. And once that's done, you can pretty much start following the course. So let's create our first file, our first application in TypeScript. It's something very, very simple. We just need to put index.ts, and here we're gonna start our new file. Let's do console log, the old and gold hello world. So this is our first project, first app. It's pretty simple to run it. You don't need to worry too much about it. You just need to come here in the console log and do tsc index.ts. And something really interesting happened. If you notice, it generated a JavaScript folder right here, a file right here. This is pretty much the result of that compilator I talked earlier. So TypeScript gets compiled to JavaScript. And well, this is pretty much the console.log. But let's do something more interesting. Let's do it now. Let's declare pretty much a constant that starts as a number and it ends as a string. You're gonna see right away that we have an error because this is supposed to be a number. Well, in TypeScript, since they did the last update, now it gets more intuitive with what is assigned, and if you don't assign anything in the start, it will probably assign the type that you are adding, which is a number right here, and it pretty much guesses that value. If you didn't want a number, you can come here and put in like a string. Of course, it's gonna throw an error because it's receiving a number. Or in this case, which makes more sense, we can add a number. And it's gonna keep throwing the error, right? Because we're assigning a string. And this is the magic of TypeScript just right there in front of you. It helps the developer don't make this confusion between variables and also types. And it pretty much avoids this, I would say, silly bugs where people don't know what they are manipulating in terms of variables. So to make it right, we can assign it a 1. If you want to do it further, we could also add, for example, one type. This will throw an error as well because it has a string in the middle of it. So we can add that to make it right. This is pretty much like the basics of TypeScript, so you were able to see it. Let's jump in on the next topics that we have to discuss, and you're gonna pretty much go even deeper on this TypeScript world. And let's jump in on the next chapter and start discussing more and more about configuring TypeScript, for instance. So in this section, we're gonna learn a little bit about tsconfig. Your project is pretty much planned right now. So in order for you to create the tsc config, the easiest way is tsc init. I'm not going to run this right now because I already ran in the past. If you come here to the file, you're going to see that there is not hundreds, but a couple of settings. You don't need to know every single setting. Honestly, no developer knows about it. You don't need to decorate or anything like that. You just need to know these main settings, I would say, that is important. The first one is target. It's pretty much tell which ES version you're gonna work on. I would leave it on 16 because it's where most browsers are adapted to receiving ESC 5. So 6 and 5, it's a good number. If you use ES8, you might come on some conflicts with certain browsers. So it should be widely used. I would say 16 is the best. This root dir is pretty much the root of our source file, where is our TypeScript file and application. We can create a source folder right here to make it better and move our index.ts there. It's pretty much standard. We normally use CRC throughout any applications. You can see that on React, on Next, and Angular, and other frameworks that also utilize TypeScript sometimes. We also should be a little bit more concerned about outdisk. It's pretty much where our compiler is going to throw our code at. Let's create a folder for that as well. And we don't need this at the moment. And so you can notice everything's AS5, the compiler throws in. And it's really important to leave it also this enable. It's pretty much if it happens any errors, it's not gonna throw out any JavaScript code or compiler. It's pretty interesting. The rest, honestly, it's not so important at all. Maybe you might need in the future, so just probably give a Google there, but you don't need to know all these settings. Later in the course, we're going to cover a little bit more about modules, CommonJS, and other types of module options. But so far, we have all the settings we need to keep on with this project. Let's give it a quick try. Right now, you don't need to specify the folder anymore. You just put in tsc and it should compile our code. So as you can see, it generated the folder, the file in the folder. It's pretty standard. And as you can see, the difference now is ES6 because we configured that right there. So it's pretty interesting, pretty cool. Let's now go on the more fundamentals part of this course and learn more about debugging, so we can later on finally enter in types and learn the really magical aspect of TypeScript. So right now we know how to start a TS project, but we don't really know how to debug it. So I added a little bit more code so you can see that happen. We have a number that is 70. If the number is greater than 50, it adds 10. Awesome. This is a normal app. A little bit more complexity to it. So the first thing you gotta do if you wanna have a debugger on VS Code is come here on the config file and uncomment this line, the source map. What it pretty much does, it creates an index.map, is this file right here. So you're gonna pretty much uncomment it and then you're gonna run ts. So let me do that with you. You uncomment this page, let's just delete this folder, you run tsc, and you're gonna notice that it's gonna generate this file on disk. what it does, it's pretty much for a debugger. Don't worry, you don't need to know that. The debugger is gonna pretty much interpret that and run the application. To see the magic happen, just come here and click right here, create a breakpoint. What's gonna happen is that the debugger is gonna stop whenever this line gets executed. So you're able to do some magic when you reach there. You're able to run your application line by line and see really what's happening with the value of number. So to see that happen, you can come here. You're gonna pretty much generate a Node.js file. It's gonna have an option here. I already have it installed. And then you just select Node.js. Remember, JavaScript and Typescript, they all come from Node. So it's just running a Node.js. And once you have it set up, it's pretty straightforward. It's 2 clicks. Unfortunately, I already did that here, but I really don't know how to undo it. So when you pretty much do that, you're able to come here and click on Start Debugging or F5. I usually use the shortcut. So right now I'm going to press F5. And you can see that this application just stopped in the line that we created the breakpoint, which is amazing. That's so helpful. From here, you can see some variables step by step on how the app is looking like. You also have some global buffers here. You can see a lot of stuff happening here. Just on this small application, you can give it a look at that as well.
Stop.
And pretty much go from there. As well, you have these options on top. You can also pull them and put it right here or right here, whenever you prefer. I usually put them right here. So from here, you can pretty much jump to the next step over, which is gonna be the if and else. And it's gonna pretty much tell you here, the number is 70, it's still 70 here. You can pretty much jump the step, so it's gonna end the code, or you can pretty much step out of everything or rerun everything, or pretty much stop the debugger. You want to see the entire code compile or the entire code run. So for this example, we can jump to the next line, and you're gonna see that the value of number right here is gonna be added 10 on the end of this line. So again, it didn't run yet. Let's jump to the next part, and then we're gonna see the number 80. So if you guys want, we can add another line here and put in like console log number, and let's rerun this so you guys can understand a little bit better how it does. So again, jumping line to line, and it's gonna see the value change to 80 because 70 plus 10 is 80 and it's console log. You can step out of everything, and that's pretty much it. So this is how you debug a TypeScript application. Of course, if you are using a framework with it, like React or Angular or Vue, you're pretty much able to use the debugger here as well in VS Code, or use the Chrome or the browser debugger that you're pretty much used to if you're doing web development. And the same goes if you're messing with TypeScript combined with React Native. You also have the debugger that React Native provides, which is pretty great. But you also can use the VS Code debugger, which is also a killer. So let's jump to the next steps and begin the fundamentals of TypeScript and learn more how we can declare multiple different types. In TypeScript, we pretty much have a lot of types. In JavaScript, we do have like number, we have strings, we have a few types there. But TypeScript introduces a lot more types, for example, any, never, and so on. Tuples, we're gonna see them throughout this section. Just to give you an example, let's create a few variables so you can understand better. So if we create, for instance, number, and we add something like this, let's just split it through a dash. When you have a huge number, you can do that. And well, we're gonna pretty much add the types, right? So this is gonna need to be a number. The next one, let's create something like name, and let's add a string to it. Let's add John. This is just compiler X doing its work. We can add also a Boolean, and we can add, for instance, a let, I don't know, change. So right here, well, I'm not going to spoil that to you, but pretty much we have a few options here, right? So instead of doing all of that, you know, TypeScript, yes, you can add the types in front of it, but TypeScript became very, very knowledgeable, and you can pretty much now just omit the type when you're declaring the variable. So when you do that, you pretty much can hover here and you see the type number. Here is a type string, and you can also add one here, and you're gonna see that's type Boolean. But there is something a little bit more different. When we come here and we see this variable that wasn't declared with any value, it comes with a type any. It's something you're gonna look forward after this section, but it's something to have in mind. The good practice normally with TypeScript is to avoid the type any because it's very, very generic. It's not something very nice and intuitive when you're coding with a large team. You normally or declare or you pretty much let it very visual what it is in the first place. Let's go and explore the any a little bit more. Let's explore the any a little bit more. So as you can see in this example, we have the change, which is declared as any, and we can add pretty much any value. It's straightforward, it's very obvious. But there is a problem there because just imagine you have that in a large application, you're just jumping in and there is a lot of any types. It's gonna take you a lot of time, and it pretty much destroys the principle of TypeScript, which is declare all the types. So if it is not implicit, avoid the any type at any cost. This is not a good practice. And for example, we add a function that adds a document or do something with a variable. And if we don't declare anything, it comes implicit with the any type. So, or you need to come here and put in any, or you need to pretty much say that this is, for instance, a string or something. It's always gonna put in the any type for you, which is something very bad. Some projects, for example, jump in right back on the tsconfig file. Some projects, they do have a configuration that is no implicit any, which is pretty much gonna throw an error for any variables that have this any type on it. Honestly, I see a couple of projects with it. Sometimes you can avoid any at all costs, but again, it depends on types of applications and goals you are setting in. I normally like to keep the any, don't make it turn into an error. I find that some documents or types or something, it has a certain limitation, specifically when you're messing with frameworks. There's always a type or a library that is not very suited with TypeScript, so the any type is justifiable. But normally you need to avoid that at any cost. So let's go and explore now arrays, which becomes more and more complex throughout this course. So let's talk about arrays in TypeScript. As you can see here, we have a couple of examples. And as usual, TypeScript is able to infer the type of array. So for instance, here is or a string or a number. But let's say, for instance, this should be only an array of numbers. So we put in numbers, square. It's gonna pretty much throw in an error for us. So you're trying to put in a string where it should be a number. You can or remove it and the error is gone, pretty much gone, or you can pretty much take it out and make it a number. it works anyways. And since TypeScript is able to infer certain types on declarations, if you don't declare anything, it's pretty much come with that famous any type, which is not so advised to use again. So of course you can add multiple kind of types to it, which doesn't make so perfect at all. It's a bit confusing. So let's say, for instance, we want this to be an array of strings. Of course, when we try to add a number, it's gonna throw in an error where we can pretty much solve it by transforming it on a string, for example this, or by just removing that line. But it's really important for you guys to understand the power of TypeScript. So it's not just like declaring types and making it more obvious for developers, it also is able to help us with code completion. And let me just show you an example. Let's say we want to loop through this array of numbers, and we are gonna do like a for each, and we have like a number, right? And we want to do something with this number. Let's say we want to do something with it, and just by adding a dot, it infers that this variable is a number, and it gives a few methods for us to use. We can transform it to a string. We can pretty much see the value of that. It's really interesting. So let's say we want to transform that into a string, and ta-da, it's pretty easy to do. It infers the types. Of course, if you're using an any type, you don't have this ability, and pretty much you kill the ability of doing that. Again, look, this is Copilot X, but also it helps Copilot X to understand that this is a string, and we can console log that if we want. So there is some benefits to it as well. So in the next topic, let's discuss about tuples. It's really important as well on TypeScript, and it's something that I'm looking forward to do. So let's see a little bit more about tuples. So tuples are pretty much a way that you can declare multiple types, for instance, in an array. Normally we use that in key pairs. So let's put in like a shop. Let's say it's a shop list or something. And we want to declare this array that has a 1, and let's say like Brad. Again, this is really nice. It's great, right? But it is kind of tough for you to declare this type because it's an array that can have, for example, numbers and strings. You can add that simply by adding this. Again, if you don't declare this type, TypeScript is gonna infer, but let's say it's in the middle of a code. You can pretty much do that, and again, it's gonna be only arrays, only number and string. And let's add, for example, a boolean. It's gonna throw an error right here. It's gonna explain that this array only takes that certain number of values. Of course, you can also do this. And you're gonna see that when you put in 1, it's gonna give you the types of that specific value that you have. It identifies it as a number. And the same goes for the string, right? It's gonna understand that this is a string. This is the magic of TypeScript. But for instance, let's say that we wanna add an item to this shopping list, and let's put in that is push. Let's push it and put in like a 2. You're gonna see that it adds without any problems, which it's a little bit of a gap on TypeScript. You can add like anything you want, and it's not gonna throw an error whatsoever. But let's test when we put in boolean, it's gonna throw the error. Look, this is just able to receive string and number. Well, that's perfect. So let's see a little bit more about tuples here. You can add more than 2 types, of course. You can add boolean, you can add array, or in any array, or any, or anything like that. But again, normally it's nice to put in only 2 types. Again, it's not nice to go like to town and put in multiple types on tuples. because it gets really confusing. It starts getting really confusing what type it should receive. So stick with 2. It's a great number, to make everything more organized. But this is an example that we can use doubles. So let's see the concept of enums. If you are very acquainted with Java, it's the same principle. It's pretty much a couple of related constants. And well, you can declare that in JavaScript this way. It's a little bit complex, there's a lot of lines. In TypeScript, you can do something more, I would say, straightforward, which is adding a size, for example, and then you can add a small, medium, and large. But there is a catch to it. Let me just comment this part. So there is a catch to that, because when you do this enum, the first value is gonna always be 0, the second 1 and 2. Those are the values that they will receive. But there is a catch. If you add, for example, a 1 here, then here is gonna be a 2 and a 3. That is pretty much the principle of enum. But let's say this is a string or another value. It's gonna throw an error because it's not capable of summing up. So you're gonna need to declare individual values for each one of them. So let's say if it is an S, here's gonna be an M, and so on. This is gonna be what we're gonna be seeing have in the enum portion of things. But let's go a little bit back and explore a little bit more about enums. Let's say, for example, that we want to change the value of this enum, or we're gonna catch another variable or something like that. We can pretty much do this. Let's add a my size, which is a little bit more different, and then we add size, which is type, the enum. Then we can get like small or medium or large. This is going to be pretty much the value from this enum. Later we can console log and do other methods with it. If we compiler that, and we are gonna see a large code, and I don't want you guys to pretty much worry about it too much about the compiler, because it's honestly not so complex to be looking at that all the time, and it's no need as well. We can, for example, create a const enum, which the value doesn't change. We can change the values if it is not a constant, obviously. And well, that's pretty much the power of enums. We can use that in rare cases. Honestly, in a couple of years of development, I have used that just a couple of times, not so much. Only in related values. Again, if it is a size, if it is something that depends on one another. But it's a nice card to have, a tree card to have when you need. Well, this was enums. Now let's see a little bit more about objects and other types that is also really useful. For instance, functions. So let's talk about functions in TypeScript. So here's a couple of examples that you can use, and probably you're gonna need to work a little bit on tsconfig. So it's pretty straightforward. You create a function right here, and then pretty much you add the variable, the number that you are required, and this is the trick right here. So most of the time, it's a good practice that when you create a function, you also specify what it returns. So when you put in, for example, void means that that function is not going to return anything. It shouldn't expect anything to be returned. But if it does return, it's a good practice as well to put in what it returns. It returns a number, it returns an array. And also there is these functions right here that normally you don't know what it returns. And as you can see, it implicitly puts on the undefined method. This is not helpful at all. Imagine a function that you don't know if it's going to return a number, a 0, or an undefined. It's not something we usually do. So in order for us to leave everything more intuitive, I highly advise you to put in this non-used parameters for true, which will help us to identify if, for example, we are putting in something declared and if we are using that variable in our function. For example, we are not using it here, not even here. So this is a good practice to have. There is also other configurations you can put in. For example, that you always need to put in the value of what is going to return, which is pretty interesting to put in on this case. For example, no implicit returns. This is also something great to have, and it's gonna throw an error right here for us to configure that and say if what is gonna return. This is really good to put on in order to be more organized. So for example, here I use this variable right now and the error goes away. Same goes here in terms of, well, let's do something with this value, and of course we're gonna remove the return 0. Now this case is a little bit more difficult because, well, we have an if, and if this if is not done, it returns undefined because there is nothing to return. So can put in, for example, a return number, for instance. Well, this is just like, for example, case. Also, there is a couple of configurations you can do on JavaScript to avoid this. When you configure, for example, a variable and you never ever use it. This is really interesting to have on, and you just need to put in the unused local settings. You see that when you apply that, probably it's gonna throw in an error and say, hey, you never used user. So we can remove that or do something with user as well. Another thing that I want to talk about functions that is really important to have. Let's take this as an example, and let's say we want to have a name that is a string, and it doesn't need to return a string. It could return only a number right here. And let's say that, well, we really don't know the value of this number, of this name. Let's say we have to do something with it, like let's say we use that if name is equal John, we add something, right? We return a variable saying, okay, so 55 or something like that. This is just for an example's sake. So let's say, for example, we don't know actually if it's going to be provided a number. We can put in a question mark. And well, this question mark, it's going to pretty much make it optional. You see that it breaks a little bit the application and the function because you don't know if it is going to be undefined because it's never provided this number before. So let's make a quick change, and let's say that number, if number exists, we're going to return number. Now we fix the error here because it's always going to return a number, our function. So this cannot also follow the optional parameter. So let's say that instead of having it as optional, we have multiple types of value that it can receive. So let's say it should receive a number. But if a number is not provided, we want to add a value that is going to be used. We can pretty much do this. So if the value is undefined or if it is not provided, it always going to be a 200. So this is something that we can utilize on this function as well. And well, this is something that we can do on Typescript and how to declare it. Now let's say we want to call in this function and use it. You're gonna see that it's pretty cool because when you first, it already identifies what is what, number and a string. And if I don't pass the necessary parameters right here, it's gonna throw in an error saying that it's supposed to have name and it's not being provided. Let's say we make another mistake and we add a number in name. It also tells us that it's supposed to be a string. So let's put in John. Now the function will execute normally. Now let's say that we don't pass number here. We're gonna have an error as well. So let's get, for example, calculate. And calculate should receive a number because it generates a constant called, I don't know, let's put in like new value, and it's gonna receive value. But if value is not true, it's gonna receive another value because we don't want to have that happen, right? We can do that as well. We can pretty much do that and use it here. Now we see that the value is optional. And if value is undefined, it's going to use 200. So we can pretty much come here, calculate, and call it directly, and there is no error happening. Or we can put in as well, I don't know, like 10, and it's going to happen as well. But when we try to put in a name, like hello, it's going to throw the error. It's pretty straightforward. It's a really powerful tool when it comes to functions, as you can see, because it helps you organize all your function code. You can add values, you can leave it optional, you can say that the function it's not going to return. It turns to be very, very intuitive to the point where the code turns to be very simple. Just imagine you're in a large application, you have this function called taxes. You never know what's gonna happen, right? Oh, it should calculate the taxes and return a yes or no. It should do an API call. You don't know. So you use Typescript to infer everything. So when you jump in on these large applications. And this is a great tool, as you can see. So let's correct the error and put it at 10. Now for the next part, we're gonna talk about objects, which is another huge thing on Typescript. So let's start seeing now objects in Typescript. So I'm gonna create a simple object called employee in this segment. We are gonna have pretty much like a basic object that will contain an ID, which is gonna be one, a name. Let's put in the first name that appears here, Mary. This is the first name I thought. And let's put in like a function to make it more simple. Let's put in like payment or payday. Let's put in the date. And this function console logs something. So as we saw in the last project we did, we pretty much need to declare this function, right? So in this case, since it is a date, there is a specific type on Typescript called date, which is pretty straightforward. And since it's not returning anything, we can put in void right here. Okay, great. So how should we declare that as a Typescript? You know, so as you can see before, it kind of already gives us the hint because it self-identifies everything. But the right way to declare that, if we were to declare that on Typescript, it would be pretty much this way. So it would pretty much do this to declare the function. Of course, there is other ways we can do it. There is really interesting ways. We are gonna see more into that in the next chapter. But for instance, we could put in also read only here, so we don't occur any changes to that specific variable. So for instance, let's put in that we want to change the ID here. It will throw an error because it's read-only, which is pretty great, you know. But let's imagine, for instance, that we receive this object, it's not a structured data, and it doesn't come with the name. Obviously, that's not a great way to declare employees, but we could put it as optional right here, or otherwise we could initialize it as an empty string or a null or undefined right here. But you're gonna see that in the next chapters, how to make it more simpler. Of course, we would need to edit this and put in undefined right here to make it more sustainable for TypeScript. But nonetheless, it wouldn't be a great way to declare the type in TypeScript, but it would be a workaround. So let's jump in on the advanced tricks so we can learn more on how we can declare our types really in an organized manner and extract the best of TypeScript as we can. So you finally achieved the advanced level with TypeScript. Congratulations! So in this section, we are going to pretty much discuss type aliases, unions and intersection between types, type narrowing, nullable types, unknown, and the never type. This is another level of complexity to TypeScript and is going to help you make your code lean and dry as possible. So you turn to be a very good professional using TypeScript. Otherwise, you would be only repeating itself over and over again. So it's really good to have these advanced steps in mind, especially when you're doing a coding interview or seeking a job. So let's jump right into it. Awesome. So since our last part in the objects segment, we face this object right here. The main problem with it is that we might use this type like throughout our application a lot. So it kind of interferes with our dry principles, don't repeat yourself. And since we are redeclaring this over and over again, there isn't a better way to do that. Actually, yes, there is. You can just declare that as a type. And when you declare that as a type, it pretty much gives you the power to reuse it throughout your application. So it's really straightforward. There's no complexity to create this type. You just put in the type, the name. Let's put in the name as an employee type, and we can copy and paste everything right here. The amazing part is that we scrap everything and we just need to use the employee part. That's amazing. So you can pretty much go into town and start declaring types on top of the variables you're using. Or even better, you can create an entire file only with the types you're going to use on that specific application if you want to be more organized with it. Of course, you can create multiple types and use it throughout your entire application. We can even create, for instance, let's say payroll. Let's create a payroll function just so you can understand the power of it. You can create a function that does that, and then it pretty much creates and logs the employee ID. You see that you can reuse this type throughout the application, and even like the code completion is gonna already know what you're trying to do, especially if you're using GitHub Copilot X. It even goes even further, and as you saw, it starts like trying to guess what the function is gonna do, and it already knows what this type is. So it was like, oh, let's just console log, or oh, let's do something with payday. It's really great tool, especially these types are magical. You might be trying to guess what is union and intersections. So let's create another function right here. I'm a big fan of arrow functions, but let's do a normal function just for the sake of the example. Let's create a conversion kind of function. So it converts kilograms to pounds and vice versa. Here it already like throws some number. Amazing. So Copilot X is doing its job. But let's say, for instance, that this function right here, it could also receive a string. So it wouldn't make much sense just to return the weight, since it could be a string or a number. So it's pretty much like a union. It's one or the other. Great. So we are receiving two specific types. So we can also call this function right here. I want to show that to you as a number or as a string. You can pretty much do that, and there's not going to throw any errors for us because this could be a number or a string. It works the same for functions that, for example, you have undefined or an object, and it could be an array and things like that, but it turns to be more and more complex, right? So let's do now what it's called mirroring. So let's imagine, for instance, that we want to see what is the type of this weight. If it is a string, we want to do a certain operation. And if it is a number, we can do another type of operation. So here he gives a hint. We can actually parse the weight to float. And then we can return it this weight and multiply by 2.2. That is something we can actually do. For the sake of organization, we can put in new weight right here, so there is no confusion, and we don't need to overwrite everything. It's just for a good principle of development. And let's say we want to do another operation, which is for when it's a number. And you guys can see that just by putting this type of, it already throws hints knowing that this variable is a string, which is very powerful. This is Typescript all over again. So let's say, for instance, that if it is a number, which is what we are expecting, if it is not a string, it's possibly a number, it just multiplies by 2.2 and it returns the value that we want. So that's pretty much what is called like union and intersections. As you can see, it really gives the hint for us and for the system as well of code completion, what is what in terms of methods that you can use. Just an example, let's put in like a console log and try to console log weight. I'm going to try to use a method, and it gives me the method of a possible string, of a possible number. And here is the same way. Let's just do that. And now it throws me hints for a string. That's like magical. This is Typescript right here. So this is pretty much what is union and intersection and the power of it. So let's go to the next section and discuss the intersection types. Let's discuss union types right now. So a simple example is, imagine you have a value, and this variable, instead of being a string or a number, it can be a string and a number at the same time. I know it doesn't make much sense to have that, but the union, nonetheless, is only the conjunction of two types. So to make things more simple, let's look at this example below. We have a draggable type, which has a function, a drag function, and a resizable, which has a resize function. The UI widget receives a union of those two types. Nonetheless, the only thing that it means is that it has a drag and a resize at the same time. So if we look here at this pretty much variable we are initializing and saying it is a widget type, it is pretty much a type that has drag and resize. Nonetheless, it's not so complicated after all. It's just to say that a type has the same thing that the other type has, and both of them mixed together is like a new type or a variable or a method. It's really straightforward, and it can save you a lot of time. Instead of you reutilizing, recreating types, you can just say, oh, it's a conjunction of two things. You add one and another, and it's this type. So it really helps with saving time and also keep things organized. So let's jump into the next challenge we're gonna face, which is pretty much literal types. Okay, great. So let's talk about literal types. They're very specific and exact. Honestly, I don't see much use on them. Hardly ever use them on a code, but it's still something very valid to use. And you can see some of that in certain applications, specifically ones that use a lot of math. So let's just imagine we have here a variable called quantity. And this variable pretty much has a value of 100. So instead of just putting that as a number or something like that, let's say something very, very specific that only can be 100. We can define that right here. As you can see, we can put in that this variable just receives 100. It's not 101 or 102 or 50. It is 100. And this is why it's literal, because it's that literal value. Of course, we can put in like another or, and it receives a 50 and make everything square. But this looks quite ugly to put in like exactly there. It could be even a little bit, created a little bit of confusion adding numbers. So normally you see that with type, so we can add a type called quantity here or exact value, and it can receive pretty much our value of 100 or 50, and it can put in right here, This also works with strings, for instance. Let's put in like a string here. Oh, no, this is a reserved, sorry, this is a reserved name. Let's put in like a text here. And instead of receiving like 100, it receives like inch, or it receives meters, let's say, or centimeters. I can put in like measure right here. So look, it's really straightforward. You can put in there as well, and you can utilize that, as you can see. If you do a typo, let's say inch, instead of inch, it's gonna pretty much indicate that typo for us. So this is pretty much where I see the use of that. Specifically for strings, I think it's a good one. But for numbers, normally you see that again on really huge applications that use a lot of math. But I don't normally see that on large applications. It's very rarely the cases that I see that happening, the exact literal. But it's nice to have under our like wing for whenever we need, we can use that. Amazing. So let's discuss about nullable types. They're not nothing like straight out of this world. It's something that you can use. So depending on the way that you set it up and configure Typescript on your application, you might not be able to use the null types or the undefined types. So I'm going to give you a quick example so you can understand it a little bit better. Let's say there is a function called greet. So it makes like greeting people. The name, it's a string, straightforward. Let's put in, instead of console logging, let's put in pretty much it says console.log hi name. I think it would be very nice, or something similar. Okay, that's great. So when we call this function, we need specifically to pass a string, right? But let's imagine we don't have this value at the moment and it's null. So it's of course not gonna work really well for us. And well, in TypeScript it's very difficult because it doesn't allow the null value. What we could do is create an if the name exists or the name is truthy, the same thing as not null, and then we console log hello and name. Else, let's say we just say, I don't know, hola, hello world, or something else. Well, even though we are handling that case right here, which is not having the name, it's still not actually working for us. So, well, what we can do about it? We can declare right here an OR operator and put it null. Well, it solves the problem for us. It's a string or it's null. Okay, that's great. But let's say, for example, we have something like undefined. We did an API call, it came, but it's undefined. Well, it's still complaining because it's not null, right? Well, we can come here and also put in undefined and problem solved. This is pretty much the null types, nullable types. I do see that a lot in TypeScript. I see a lot of applications that don't really allow the null value, but yeah, I quite see that often, especially when you have API calls and you're not sure if you received the name of or something in an unstructured data set like MongoDB. That's very, very normal. So this is how you can handle that case. So let's look at our last advanced tip right here is optional chaining. So just imagine a case like this one. We have a customer who has a birthday, and then we get a function that does something with the customer and returns a value. It returns from the ID, it returns customer, or it could be null, right? It could be an API call that could go wrong. So instead of doing all of that, because imagine if customer is not null and you also need to put in if it is undefined and then you add an operator undefined, it starts to get very lengthy, right? As you can see, there is a better way to do that because it's not possible. And if you don't actually put in this, you could get an error right here because imagine it is undefined and you don't put in this and it could be like an undefined. Again, it starts giving the error. So how we can reduce that and make our code more lean? Well, there is something called the chaining operator. So the only thing that you gotta do is put a question mark before the element that could be undefined. So it's the same as creating the if, but it's more lean, right? It's easier for you to use in the case of a large application or something similar like this, and it makes our code to execute better, right? So let's imagine, for instance, that we make birthday optional as well, and let's say we have like some method with birthday that we want to use, but we are not sure if it is also undefined or no. We can put in another operator here and get like full year or something out of it. Oops, it's a bracket. So as you can see, we can start chaining those because we don't know if it is undefined or null or anything like that. And it starts to get very interesting, this kind of chaining, right? Of course, if you start using that with inline, it's gonna get messy. It's gonna get very confusing. But in this case, in this scenario, it makes sense and it looks more lean. We can also use this operator in other ways on our code. For instance, with arrays and even with functions itself, it can be used. So for instance, for customer, let's say we want to get in on, like, let's say there is an array of customers here. I'm gonna just comment that out because it's gonna throw an error. Let's say we want to access the first element, but it could be undefined or null. Well, we can do that like this. It looks kind of different and weird, but yes, we can do that. So if it is not null or not undefined, it's gonna get this element. And well, this is pretty much how you can use optional chaining. It's a really interesting way of letting your code lean and always check if the type is undefined or not. So pretty glad we reached this point. Now you have all the advanced tips on TypeScript on how to define the types. You know about tuples, objects, functions, enums, and a lot more. So I feel that you are very, very confident to start your own project. So let's just jump in on the next part and discuss a little bit with what changed on TypeScript so far in 2023. And let's do some like guessing on what's next for TypeScript. Happy to conclude this course. Before we end everything, it's really nice to go over a little bit of what TypeScript has been doing recently and the news about it. So you guys can go and read a little bit about the patches and see what else you guys can study. Of course, it's always great. Technology is always changing. So it's really interesting because right now it just announced the TypeScript 5.4 beta. And these new updates on TypeScript, the majority of them are just updates making the language itself more interactive and more intuitive. So, you know, type checkings and fixing bugs and letting the code learn more and be more proficient at guessing the types of elements. But without further ado, in this last patch, I noticed that we had the introduction of no-infer, which is calling a generic function and adding some types to it. Nothing really new and amazing, but it's another way of declaring types. And we also see some updates in terms of TypeScript inferring the values of functions. So it's really nice. I'm gonna leave down below in the description the drive with this presentation, with all the code base that you saw in this course, and also a link for the new patch 5.4 so you guys can give it a read. It's very, very, very large. It has a lot of nice updates. Even declaring types on imports now, it's something. So it's really nice to give it a read. It's very intuitive, nothing super new, but it's nice to read to keep it updated. Also, it introduced extends, which we pretty much it can extend a type and add more types to it. It's something new on TypeScript recently, but honestly, I haven't seen that in use so extensively, and it's pretty much like adds another layer of complexity for TypeScript. I don't see a lot of people adopting that. But it's nice to give it a read, and well, sometimes you can see that on a code base. Well, this is it for this course. Feel free to follow me on social media, Henry Fadoni, specifically on LinkedIn. Give me a shout out there. Happy to give any guidance for anyone that needs. And well, hope you enjoyed this course.